9F, differentiating rational powers. Differentiating rational powers is exactly the same as differentiating any other integer. A rational power is simply referring to a number that can be expressed as a fraction. So differentiating this fraction is going to be the same as when I differentiate a regular number. I pull the power out the front and then I subtract 1 from the power. I guess it's going to look a little bit different because we may have square roots there, or any kind of roots. All we need to do is first simplify it and then we can differentiate it from there. The problem with this one also, just from looking at it visually, is that it's a function divided by another function, which at this stage we still don't know how to differentiate. So before I can proceed, I definitely need to do some sort of simplification in order to be able to differentiate this. First thing that I can see is that I have square root signs at both the top and the bottom. So I'm going to now change these to powers of a half. What I can recognize up at the top is that this is x squared minus 1, which is in the same format as our dots, which is a squared minus b squared is equal to a minus b, a plus b. So I'm going to further factorize the top there. And that is all to the power of a half. And remembering that every single value within a bracket receives the power. So that's the same as x minus 1 to the power of a half times x plus 1 to the power of a half, also not forgetting the power of the half at the bottom there. And now hopefully what you can see is that both the bottom and the top have x minus 1 to the power of a half, so I can simplify these. This will essentially divide with that one, which will leave over x plus 1 to the power of a half. Now we haven't differentiated yet. This is still g of x. I'm just transforming it into a type of function that I can actually differentiate. So that it's in a form that I can differentiate it, I can go ahead and do so. I will need to use the chain rule. So first of all, I'm going to pull the half out the front and then subtract 1 from the power and multiply it by the derivative of the inside, which in this case is just 1. So that will be a half x plus 1 to the power of negative half, and this can be expressed as 1 over 2x plus 1 to the power of a half, and you can take it that one step further to write it as 2 root x plus 1.